In this experiment, we learn to manipulate and process the digital images to achieve a particle tracking velocimetry, which tracks the displacement of an object from consecutive digital images. This method is also called PTV technique. This PTV technique is applied to analyze the free fall dynamics of a fully immersed solid sphere in a liquid tank. Its descending velocity can be used to infer liquid viscosity and hence resembles the falling sphere viscometer. The sphere freefall process will be recorded by the high-speed camera that is set at the lateral side of the reservoir. You will place a cell phone at the reservoir lateral wall. The timer in the cell phone should also be recorded as the digital image's time reference. These timer images will be used to understand the influence of image, recording, and exporting rate in the post-analysis. With the time and position information from the images, we can calculate the falling velocity of the small solid sphere. Of course, it requires image processing routines to extract the sphere position from an instantaneous digital image. Now we look at the experimental facilities and procedures. Here is a tabletop plug-and-use viscometer. The experimental liquid is put in a beaker, and then the spindle rotates in the center of the beaker. The torque required to maintain the constant rotation is used to calculate the viscosity. This measurement gives a viscosity value for comparison and later analysis. As for the densimeter, its non-weight is balanced by buoyancy from the test liquid. Hence, by reading at the immersion depth, we measure the immersed volume and back-calculate the density from the buoyancy. The tank is filled with the test liquid, in which we shall drop the test object to observe its dynamics under the action of gravity, buoyancy, and hydrodynamic force. As liquid viscosity and density change with its temperature, we measure the temperature with a thermometer to understand the measured value. Align high-speed camera to make the filming angle perpendicular to the tank's front surface, so that the sphere images won't distort or affect the image processing results. Attach a cell phone on the side of the reservoir. Activate the stopwatch app in the cell phone to show time up to the millisecond resolution. Turn on the LED light on the back. Focus the lens and adjust the aperture of the camera so that a clear image is obtained at the center of the tank, where the object should pass. Adjust the camera position until the lower 2/3 of the tank. Stopwatch app and the reference scale are clearly covered in the image. Drop a densimeter into the tank. When it stops sinking, read the density. Turn on the LED light on the back. Drop a sphere into the tank and record its falling track. Use a digital image processing tool to track the particle, so that post-analysis on the sphere dynamics and the hydrodynamic forces can be evaluated.